In this next example, you aren't actually doing a problem. You're just looking at how matrix multiplication can be used in some real life problems. So we have beef, chicken, and vegetable pies that are sold on Monday, Tuesday, Wednesday, and Thursday. The beef pies, cost $3, chicken costs $4, and vegetable pies cost $2 each. So to figure out how much you're going to make each day, you would look at, for instance, on Monday, you would multiply your $3 that you make, or that your beef pies cost, times how many you sold on Monday, which is 13. And you'd add that up with your next amount, which is your $4 that your chicken pies cost. And you sold 8 of those on Monday, times, you also have to look at multiplying your $2 times which is your cost for your vegetable pies, times the 6 pies that you actually had for vegetables on Monday. Okay, so we have $3 for each of the 13 beef pies, $4 for each of the 8 chicken pies, and $2 for each of the 6 vegetable pies. And then we would add that all up, and that gets you a total of 83. Notice that's exactly what you do when you take the dot product when you're looking at matrices. And I just want you to realize this is a real life application of taking some data and how to work out matrix multiplication in a real life situation. Some other comments that have not been mentioned yet is that matrix multiplication is very special because multiplying a matrix A times B will get you one answer, and multiplying B times A will possibly get you another. Because of the way the multiplication works, it is not communicative, which means you can't just turn it around. 2 times 4 is the same thing as 4 times 2, but that is not true with matrices. For example, suppose a matrix A is a 2 by 3 matrix, and matrix B is a 3 by 2 matrix. Those you can multiply because the 2 inside dimensions do match. And the result would be a 2 by 2 matrix. But another side comment about multiplying matrices is when we multiply a matrix A times B, or when we multiply a matrix B times A, you do not get the same value. Actually, one may be possible and the other may not. We're used to, with real numbers, things like 2 times 4 equals 8, and 4 times 2 also equals 8. So switching around multiplication normally does not matter with real numbers, but with matrices, it does. For instance, suppose we have A and B that we're multiplying. A is a matrix that is a 4 by 2 matrix, and B is a 2 by 3 matrix. Notice you can indeed multiply these two because the 2 interior dimensions do match, and the result would be a 4 by 3 matrix. So our answer, whenever we would get it, would be some kind of 4 by 3 matrix that we'd get. But if we were to switch this around and look at B times A, again, B was a 2 by 3, A was a 4 by 2. Notice you couldn't even do this multiplication because the 2 interior dimensions, 4 and 3, don't match up. So this would be not even possible. So be careful when multiplying matrices as to whether or not it's possible or not. This is a big